What if everything that has ever existed in the universe got crushed into a single point? The universe started with the Big Bang, but could it end where it began? This hypothesis is known as the Big Crunch. To fully understand the Big Crunch, we need to go back where the idea originated. In late 1915, Albert Einstein had just published his theory of general relativity, but something in his equations was at odds with his assumptions. Einstein initially believed in a static and eternal universe, but based on his own work, if the universe was static, it would inevitably collapse under its own gravity. He did something that he would eventually refer to as his greatest blunder. He would add something called the cosmological constant. The cosmological constant is basically an invisible outward force that counteracts gravity. This allowed him to keep his idea of the static universe alive. In 1924, mathematician and physicist Alexander Friedmann took Einstein's equations and fundamentally changed the way cosmologists thought about the universe. He was able to find solutions for Einstein's equations, whether the universe was expanding, contracting, or static. He was also the first person to mathematically model what a contracting universe would even look like. In 1927, theoretical physicist Georges Lemaître proposed that the universe had a beginning, what we know as the Big Bang Theory. But if the universe had a beginning, could it also have an end? Lemaître thought so, and one that mirrored the beginning. In 1929, Edwin Hubble directly observed that galaxies are moving away from us. This was the nail in the coffin for the static model. This sent cosmologists down the path of abandoning the static model entirely. While Hubble confirmed the expansion of the universe, nothing ruled out the idea of a reversal. In cosmology, omega represents the density parameter. If omega is equal to 1, then the universe has zero curvature. It will expand forever, but the rate of expansion will get asymptotically closer to zero. If omega is less than 1, then the universe isn't dense enough for gravity to halt the expansion, so it expands forever until everything across the universe is the same temperature and no more interaction can occur. And if omega is greater than 1, this means that gravity will eventually become stronger than the expansion, and the universe will collapse back in on itself. This is the one we're focused on today. 1998 was a massive turning point. Scientists Saul Perlmutter, Brian Schmidt and Adam Riess were studying a supernova, and they discovered that the expansion of the universe wasn't slowing down, it was actually speeding up. Dark energy was the mysterious force accelerating the expansion. While dark energy isn't fully understood, its effects are very real. In 2011, they were awarded the Nobel Prize for this discovery, and it dethroned the Big Crunch as the leading theory of how it will all end. Although new observations from an instrument called decay are starting to revive debate about this theory, we'll save that for later in the video. Now that we've gone through the history, how would the Big Crunch actually happen? Remember how we talked about omega being greater than 1? This is exactly where it comes into play. For the Big Crunch to have any chance of happening, dark energy must weaken or reverse entirely. We don't fully understand how dark energy works, so this is speculative but not impossible. At the current expansion rate of the universe, it would take billions of years to finally notice a meaningful deceleration. Distant galaxies will stop redshifting, and the night sky would look quite a bit different. Once gravity gets the upper hand, galaxies start creeping back towards each other and the universe starts to contract. Dark energy has officially lost the battle. A few million years before the end, galaxies will start merging together faster and in greater frequency. The cosmic microwave background radiation starts blue shifting and heating up. The sky is significantly brighter, and galaxies that were once faint glowing blobs are now visible to the night sky, if you were still alive. A few thousand years before the end, every galaxy is now merging together, and stars are breaking down. The ambient temperature of the universe is now hotter than stars themselves. Everything is becoming a molten cosmic soup. In the final few seconds, matter is being broken down, atoms are torn apart, protons and neutrons break down into quark, glue and plasma. Everything that has ever existed in the universe is being crushed into a singularity. Temperature and density are headed towards infinity. At the singularity, we honestly don't know what happens. Our understanding of physics simply doesn't explain what happens at or beyond the singularity, but we can speculate. But even with the Big Crunch, many physicists believe that it would inevitably lead to another Big Bang. The Big Bounce comes from the field called loop quantum cosmology. It says that at extreme densities, our current understanding of quantum mechanics may prevent matter from fully collapsing into a singularity, so instead of being crushed down to a single point, it would hit a barrier then start the expansion again. The ekpyrotic model is a bit more speculative. It comes out of string theory and says that there are membranes floating in higher dimensional space that periodically collide. These produce a new Big Bang, and it repeats endlessly. I know, my brain broke when I was learning about this too. This is in contrast to the heat death where all matter in the universe will eventually reach an ambient temperature, and no interactions will happen for the rest of time. The vast majority of the scientific community favors the heat death hypothesis based on our current understanding of dark energy and the observations of the universe expanding. But as we mentioned earlier, there were observations from an instrument called decay that is questioning how we think about dark energy. Based on data, it's giving indications that dark energy may be weakening over time. But this is still brand new research, and it hasn't quite reached the threshold to be labeled a scientific discovery, but the scientific community is actively debating its implications. It will likely be debated for decades or longer. Dark energy is still one of the biggest mysteries in the universe, and what we learn about it can completely change our understanding. If you're interested in learning about the heat death or any other ways the universe might end, hit subscribe so you're notified when it comes out.